Keep seeing science memes about how traveling at the speed of light and you return to your initial destination, that people age differently. So anybody who were to stay at their home, right, is at a different age. I'm going to explain why that doesn't work and why T equals C. So Einstein's light clock, maybe I explained this in a video a while ago, I don't know, but I think I might explain it slightly different. So the observer, say you were on the train with the light clock versus being the observer. And so the train travels from point A to point B, and he gets there, so however fast, right? So the observer then has to check the light clock. He has to walk to where the train got to. He doesn't travel as fast as the train. So he ages at that same amount of time, while the guy on the train ages the exact amount of time it takes the guy to walk. They both age between point A to point B, because the observer is stationary versus the guy riding the train. And as he gets to the train to check the light clock, then the guy riding the train ages the same amount of time that it takes the observer to walk to that train's destination. So as the light clock speeds up, the increments of measurement, and I did explain this with my rubber band. I showed me my original way of explaining it, how you disprove the light clock with the rubber band. The time's not warping. What is actually happening is you're increasing measurement. So as velocity increases, the point of reflection for a photon to take a time when it's straight up increases distance. So you have to keep shrinking that, right? So then as you get so far down, eventually the increments of measurement are the width of a photon. And so the photon effectively is traveling in a straight line. It's touching both increments. And that's at the speed of light, right? So time stops. Well, it doesn't actually stop. What happens is it becomes immeasurable. You can't measure it with a light clock. And so T is constant. T is the same thing. Time is then the same thing as our constant. T equals C. Well, but you still have light traveling from distant galaxies to reach Earth. You have it traveling from the sun to reach Earth. And the time it takes light to travel from the sun to Earth is no different than you being the observer. It's just that the light train is, point A is the sun, and its train is a photon.